Okay, this is going to be an example of integration by parts, in which you can see we have sort of two separate entities here, and the formula that we're really working through with integration by parts can be written like this, where we have the integral of u dv is going to be equal to uv minus the integral of v then du. This is kind of the template that we start with, and we need to express this in the form of a u and then a dv. And to help us decide which is going to be the u and which is going to be the dv part, we have this helpful little memory device, which is Liate, or however you want to pronounce it, in which we're going to work in order of priority, first with logs, then with inverse trig, and then algebra, and then trig, and final priority is exponents. So if we go through and diagnose this one, we would say that, okay, this is an exponential, that's an e, and this is a trig. So e comes at the end, t comes before that. So I'm going to let my u part, my u, come first and be the trig. All right, so I do this little chart here to help me stay organized, and that's my u, that's my v, there's my du, and there's my dv. All right, and so like I said, I'm going to let u be the cosine of 2 theta. So then when I take the derivative of that, I will get du be, well, the derivative of the sine is the cosine, derivative of the cosine is the minus sine of 2 theta, and then when I take the derivative of the inside, that's going to be 2. I'm just going to write it down here, times 2, and then I have to have the d theta. All right, got a little crowded there, I apologize. Then if I work down from here, after assigning the u, I'm going to take the leftover bit, that's these two things together. So I have dv then is equal to e to the minus theta and then d theta, and then I work upwards on this side to integrate and say, well, the integral of this then will give me v, and when I integrate this, I'm going to get minus e to the minus theta, right? And you can always check your work. If I take the derivative, yes, that minus would cancel out and I get this. Okay, well now I can put it into this template where I have this is my u part and this is my dv part. Well, this is going to be equal to then u times v, so I'm just going to multiply these, minus e to the minus theta, I'll put that out front, cosine of 2 theta, that's this part, and then minus the integral, where it's the integral of v, well, minus that, I guess I'll just write it straight up, but I could bring the minus sign out like that, and then the du part is another minus sign. Actually, let's yeah, I'll make that a minus there and a 2. There's the 2 that I was multiplying into 2 sine of 2 theta and then d theta. All right, well, what do I do? Usually you're hoping that this is something that's easier to integrate, but unfortunately it's very much like the first one. I'm going to just cancel out these minuses, all right, because they would do that. And I could bring the 2 out front if I wanted to and write the 2 out there, cancel that out. But still, I have essentially the same type of thing. Well, do not despair, just persevere, keep going, and I'm going to do the same thing again. So I'm going to take this and make another little chart, give myself maybe a little bit more room. And I've got u, and I've got v, and I've got du again, and dv again. And what am I going to assign? Well, the same sort of thing is going on. So here's my trig. So I'm going to make this be the sine of 2 theta. And when I take the derivative, I know it's going to be 2 cosine of 2 theta. And then I still have to sneak in the d theta down there. All right. Well, what is my dv? It is e to the minus theta and then d theta. This is looking familiar, and when I integrate that, I'm going to wind up with minus e to the minus theta. Okay, again, we're just going to keep going. So I've got minus e to the minus theta, cosine of 2 theta, that doesn't change, minus 2, and then inside this, right, is going to be another one of these parts here, where it's u times v, so that's minus e to the minus theta times the sine of 2 theta, okay? And then minus the integral of, and then this is going to be my minus e to the minus theta, then times 2 cosine of 2 theta d theta. Okay, well, here I've got this minus sign. I can bring that out front. That's a plus, and then that will go away. And then when I bring in the 2 into each of these, I will wind up with minus e to the minus theta cosine of 2 theta. And then this is going to be a minus, and a minus is plus 2e to the minus theta sine of 2 theta. Plus then, when I bring in the minus, this 2 right here, I'll bring that outside and I'll multiply it by the minus 2, so that's going to be minus 4 e to the minus theta cosine, there's an integral there, cosine of 2 theta d theta. And what you'll notice here is that we've got this thing right here, which is exactly equal to our original problem at the beginning. All right? And I've got 4 of them here and 1 of them the other side. So when I add 4 of this integral here to both sides, you'll see that my original, 1 of them, plus 4 of the exact same thing here will give me 5. So I write 5 integral of e to the minus theta cosine of 2 theta. And what is that equal to? It's equal to minus e to the minus theta cosine of 2 theta plus 2 e to the minus theta sine of 2 theta. And now if I simply divide everything by 5, lo and behold, I have solved my original problem. It is equal to this. And I can slap on a plus c, and I'm good to go. Thank you.